This is the second help video for pages 17 through 26. Taking a look here. Now, because you're going to have a multiple choice test, yes, absolutely, take a split second and see what the question's actually asking. And it's asking for the arc TQS. TQS. But then ignore what it's asking for and simply find everything possible. Don't focus on only that. So you just kind of take a look and see, well, what's possible? And if that's the center of the circle, we have a diameter here, which means this right here is going to add up to 180. So I can do 6x plus 5 plus 12x plus 2 plus 65 equals 180. Now, obviously, when I solve for x here, I want to pay particular attention to solving for this wedge, because then to get this yellow arc, I simply add 65 plus 180 plus that wedge, going around this way. 65 plus 180 plus that wedge. Find the area, but you're given the circumference. So, C, D pi, I see D pi. Apple pie is really, really good. Start with what you have, not with what you need. Obviously, the pies cancel. That gets you your diameter. You just draw a picture. It's always a good idea to draw a picture. That's the center of the circle. You just found out that your diameter all the way across is 14. Obviously, for area here, you need the radius. Keep it in pi form unless you're told otherwise. These two, this one is length of the arc. This one is area of the sector. They both have the same idea. Arc length is simply a fraction of circumference, and sector area is fraction of area. So that would mean arc length is theta over 360. That's fraction. Of means multiply. Circumference means d pi. Down here, fraction theta over 360 of multiply area pi r squared. You want this in exact terms. Arc length equals. So right here for this problem, we are doing for this length of the arc, which is a fraction of the circumference, 210 over 360 times, always trace your diameter, always, always, always. That's not 6, but 12, and of course pi. Get in the habit of trying to reduce without a calculator. And your arc length here turns out to be 7 pi meters. Arc length is a fraction of the circumference. Sector area is a fraction of the area. Couple things going on here with inscribed angles, just general principles. Inscribed angles are angles which are on. This is where you use the post-it notes. So there's inscribed angles. Think head on, arms in, hands. Imagine this is hands grabbing the arc. If you have post-it notes, you'd be posting your post-it notes on either side of that vertex. Two simple truths. This angle is half of the arc it's grabbing. That's one truth. Another truth, if you have an inscribed quad of any kind, inscribed, where all four corners are on, opposite angles add up to 180. That's two truths when you're dealing with inscribed angles and inscribed quads. So, taking a look here, knowing those two truths, if your post-its are like this angle right here is half of this arc that it's grabbing. So you go 81 times 2, 162. And then you ask yourself, what else can you find? Well, you only have one more arc left right here, the blue, so I'm going to do 58 and 162. And we get this mystery arc to be 140. Now, you just find everything possible and then look what it's asking for. Well, we just found the 140, but you could also find this, and that would be 180 minus 81. Of course, this would be 99 because they add up to 180. This is an inscribed angle. Once again, your post-it notes, if you had them, would be like this. And this angle in this arc, there's two ways to express it. The red angle is half of the arc. That's one way to express it, which would make it look like this. 8x plus 2 equals 1/2, 15x plus 11. But most of you, that kind of makes you uncomfortable because now you're distributing a half sign, if you will. Or you can think of it like this. The arc is double of the angle. That might be a little bit easier to digest. So that's 15x plus 11 equals 2 of 8x plus 2. Both will get you the same thing. Solve for x, find the arc that's being requested. Couple things you want to watch out here for here. Couple truths is if I have a radius and a tangent. If tangent to a radius, radius, if tangent to a radius, right angle at the edge. That'd be one thing you want to watch out for. It's right angles. Also, two radii our radii are always congruent, so you want to watch out for isosceles triangles. Knowing that, take a look here. We're going to start by sweeping this angle and then just keep going. You can see that's a linear pair, adds up to 180. Remember what I said about isosceles triangles? That's 2 radii, so those are equal. That means this is 43 as well. (180 minus 86). (94). I just keep working it. That makes this 86. If tangent to a radius, tangent to a radius, right angle at the edge, watch out for the giant right triangle there, and you have everything you need to find that. We're going to write an equation of the circle. There's only 2 things you need an equation of a circle, and that is a center and a radius. There's only 2 things you need. You need an HK, which is the center, and a radius. Now here, for this problem, we've been given our H, we've been given our K, we are missing the radius. What have we been given? The area of a circle. So pi r squared, 64 pi. Radius equals 8. Now you have everything you need. X minus h parentheses squared, y minus k parentheses squared equals radius squared. Plug it in. -7 here, 4 here, 8 there. Bring down the equation and clean things up. It says find the volume. Volume of prisms is area equals base times height. This is a prism, volume equals base times height. This is a pyramid, volume equals base times height over 3. This is the one we're going to do together. So volume equals base times height over 3. Always shade your base. Always, 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 always shade your base. Shade your base, shade your base, shade your base, shade your base, shade your base. That helps your brain register what the shape is. It is a right triangle. So for my base, I am going to do leg times leg over 2. That's going to equal my base. Why? Because it's a right triangle. My base is going to be 6 miles squared. Now I have everything I need. 6 times the height of 6 over 3. Don't forget units. Here, watch out, the bases are the 2 trapezoids, front and back. Do the following in terms of pi. That means we're dealing with circular type stuff. Volume equals base times height over 3. We have a cone here. Shade your base. It's a circle. Watch out there. 6 is the diameter. It means our radius is 3. So our base is pi r squared. 3 squared. Pi times our height, which is 9 over 3. This is a sphere. Volume equals 4 pi r cubed over 3. That's for a sphere. For a cylinder, volume equals area of the base times the height. It says each pair of solids are similar, same shape, different size. Instantly, you should be keeping track. The minute you know something is similar, there's a 1D ratio, a 2D ratio, and a 3D ratio. Always. Says we want to find the scale factor, left to right. Scale factor is 1D. Let's look at the information we've been given. We've been given the volume. So take a moment, since that's the actual volume, we're going to try to reduce these. I'm going to reduce simply by dividing by 2 and see what we get. 56 divided by 2. That's going to get me 28. This divided by 2 is 3500. We can still divide by 2, so I'm going to keep going. Dividing by 2 gets me 14. Dividing by 2 here, 3500 divided by 2, 1, 7, 5, 0, so 1750. I can still divide by 2 again, which I'm going to do, and I'm going to get 7. And so now I'm going to go 1750 and see if it's divisible by 7. Doing all of this longhand. 7 goes in there twice. 14, 35, I'm going to start dividing everything by 7 here. I think 2. Let's try that. Divided by 2. I lost track of my divided by 2, so I'm going to keep it color-coded here. 56 divided by 2 is 28. That's 34. 0.500. We're going to color code divided by 2 divided by 2. This gets me 14, of course. And we did 3500 divided by 2, and that is 1750. So that's 1750, green to green. And now we're going to divide by 2 again. And we get 7 here. And 2 goes into 1750. 2 is going to go in here 8 times, 16. 2 is going to go in there 7 times, 14, 108, 75, 875, and then now I'm going to try 7 goes into 875. And that's a 1. That's a 2. And that's a 5. So we got it done. There it is. 125. Got it. Okay, lost track of my divisions here. So our 3D ratio is 1 to 125, which is x cubed to y cubed. It's asking for the scale factor, which means in all of this, what is your x and y? Well, 1 times 1 times 1 is 1. Cube root of 125 is 5. Therefore, your scale factor would be 1 to 5. Number 33. This is a secant, so it's angle equals big arc minus little arc over 2. 45 would be the angle. Our big arc is our unknown minus little arc, which is 70 over 2. Pop it over 1, cross multiply, solve. Write an equation of the line according to the circle. Equation of a line. All you need is a center, which is an HK, and a radius. What have we been given? We've been given the center of 310. There's your HK. Let's plot that. So our center is over 3 up 10. That is our HK. But it's tangent to the line y equals 2. So y equals 2 is all the points where y is 2, and that's a horizontal line. Y equals 2. Now, the trick to this is knowing that a radius and a tangent always makes a right angle. So when I go like this, my circle is going to go around like so. There's my imaginary circle. There's my radius that I need. And you see right now, all you have to do is count the distance from the center to that radius tangent point. So it's 1, 2, 3, 4, 5, 6, 7, 8. So my radius is 8. Now I have everything I need. X minus h squared, y minus k squared equals radius squared.